Oh, good morning, students. I have a special surprise for you. Check it out. We're talking to Kyla. Say hi, Kyla. Say hello, Kyla. Uh,
Hello.
where am I? I'm right here, Kyla. All right, Kyla. I gotta get going. Okay. All right. Have a good day, sweetie.
I'll push you back in.
All right. Push the button. Bye bye.
Mama.
All right. Push the button. Bye bye.
Mommy.
All right. Have a good day, sweetie. I have to go. Bye bye. All right, students. Thanks for enjoying. I hope you enjoyed that. That was my daughter Kyla. Uh, on Wednesday mornings. Wednesdays are weird, so I don't get to see her in the morning. We'll talk about that some other time. I guess. You know. Oh, wait. All right. Here we go. So, what we're doing today is we're doing our third day of rational functions, and we have the two parent functions. The two parent functions being y equals 1 over x and y equals 1 over x squared. Um, and today we're going to be adding dilations and reflections to the problems. We're going to start off with y equals 3 over x. So what we're doing is we're taking that parent function y equals 1 over x, and you're multiplying it by 3, which it's always been. That is a vertical dilation. I'm going to go a little shorthand today. Vertical dilation, arrow 3. Vertical dilation by a factor of 3. But I'm beginning to like this kind of shortcut. And because it's only a vertical dilation by a factor of 3, that means that we're going to take that y coordinate, the y coordinate, and multiply it by 3. We are not going to do horizontal dilations with these functions, and we'll talk about reflections in a minute. So those two key points for the parent function 1, 1, or for the parent function y equals 1 over x, we have 1, 1, which would become 1, comma 3, and we have the other point, negative 1, negative 1, which becomes negative 1, negative 3. And then the rest of the graph would be exactly the same. Now, when I get to the point of drawing the graph, I always know that these graphs are going to look exactly the same every time. They're going to look like basically like this, because I'm not using graph paper in these situations. And actually, that was really not a good job of drawing this graph, but it is what it is at this point. And there was no translations, so this one's at y equals 0 and this one's at x equals 0. And then this key point right here, instead of being 1, 1, is 1, 3. And this point, instead of being negative 1, negative 1, is negative 1, negative 3. That's all that a vertical dilation does. For people using graph paper, a vertical dilation of 3 means that this point will always be 3 units away from the asymptote, from the horizontal asymptote. Instead of being 1 over and 1 up, it's 1 over and 3 up. Okay, let's take a look at number 2. This one we're going to multiply 1 over x squared by negative 2. So I'm going to set this up first. I have my xy, and because it's 1 over x squared, my two key points are 1, 1, and negative 1, positive 1. And we have two dilations here. We're multiplying by 2, so it's a vertical dilation by a factor of 2. But then we're also multiplying it by a negative, and that negative is on the outside of the function, negative 2 over x squared. So that's also an x-axis reflection. And x-axis reflection, when you think about what it does with the xy coordinate, it becomes x negative y. When you think about an x-axis reflection with terms of the asymptotes, it simply means that instead of this graph going up, the graph's going to be going down. So you will see x-axis reflections. You will not see y-axis reflections, because when you think about it, when your parent function looks like this, if you do a y-axis reflection, you get the exact same graph. So there's no point of a y-axis reflection, but there is a point to an x-axis reflection. Now, what would those key points become? Oops, I messed this up. I put x negative y, but because of the vertical dilation of 2, it would be negative 2y. All right, so these new coordinates, x stays the same, so 1 and negative 1. These ones get multiplied by negative 2, so negative 2 and negative 2. So this key point right here is 1, negative 2, and this point over here is negative 1, negative 2. There you go. For people, oops, I forgot to label my asymptotes. Y equals 0 and x equals 0. And like I said before, if you're using graph paper, I would just think about it this way: vertical dilation of 2, x-axis reflection. That tells you what the graph is going to look like. And then this point here, instead of being 1 unit from the asymptote, is now 2 units from the asymptote. All right. So that's example 5. That's the one I'm going to have you do on your own at the end. See if you are understanding what's going on. Where are examples 3 and 4? Here we go. Example 3. So now we're going to add some translations into the mix as well. We have the parent function of y equals 1 over x. I've just realized I haven't been doing all of the instructions with those previous problems. I'll go back to that in a minute. Those xy points that we usually use are 1, 1 and negative 1, negative 1. And in this case, you're multiplying it by 4. So that's a vertical dilation by a factor of 4. And x plus 2 on the denominator, left 2. What that's going to do to the coordinates, if you're going left 2, that means you're going to subtract 2 from the x coordinates, and you're going to multiply the y coordinates by 4. So our new coordinates will become 1 minus 2, which is negative 1, and negative 1 minus 2, which is negative 3. And then when I multiply these by 4, you get 4 and negative 4. All right, so now this graph, even though it's got a little bit of changes, at the end of the day, it's going to look just like every other problem we've done in this case. There's no reflections, so it's going to look like this. If you're going to use graph paper, you're going to see the vertical stretches a little bit more. But at the end of the day, because we were going left 2, this is x equals negative 2. It's not going up or down, so this is still at y equals 0. And that's going to make this point the negative 1, 4. And this point the negative 3, negative 4. For people using graph paper, once you have those asymptote drawn at negative 2, you just need to go over 1 and up 4 because of the vertical dilation of 4. People using graph paper, definitely these are a lot easier for you, over 1 and down 4. But it should look basically the same except with this vertical stretch. Okay, I didn't do part B of numbers 1 and 2, but you're not going to get quizzed on problems like 1 and 2. You're going to get quizzed on tested like on problems like 3, 4, and 5. So I'm going to do the domain and range for these ones. The domain, it includes all values except for negative 2. So you could say negative infinity to negative 2, union, then you pick up at negative 2 here and it continues on to infinity. The range, it starts at negative infinity, gets up to 0, then it stalls out, but then it picks up over here close to 0, and it continues all the way up to infinity. So the domain and range. All right, if you have any questions at any point, you should stop watching this and ask me in class. All right, example 4, an everything problem. This has a little bit of it all. First of all, think about my parent function. It's y equals 1 over x squared. My xy coordinates are 1, 1, and negative 1, 1. Then we have a the negative in front, x-axis reflection. This 3 up top, vertical dilation by a factor of 3. Plus 2 on the end, up 2. Inside the function in the middle, right 1. The only thing that's going to affect the x-coordinate is this right 1, and that's going to be x plus 1. Now, you've got a x-axis reflection with a vertical dilation of 3, so negative 3y. And then after that, it's going to go up 2, so plus 2. 1 plus 1 is 2. Negative 1 plus 1 is, negative 1 plus 1 is 0. Oh, yes. And let's see, negative 3 times 1 is negative 3, plus 2 is negative 1. And this has the same y value, so it would have to be the same y value here. All right, now, even though it has all of these reflections, it's still going to have these two asymptotes, so I still draw those first. There is an x-axis reflection, so I know that this graph is going to go down. And let's see, it went up 2, so this is at y equals 2. It went right 1, so this is at x equals 1. And then because this is 1, that means that this point would be the 2, negative 1, and this point would be the 0, negative 1. People using graph paper, I really recommend doing this. Figuring out where your 0, 0 is, then put in your vertical asymptote and your horizontal asymptote, label it y equals 2, label it x equals 1, and then because this is at x equals 1, that guarantees that these two key points are going to be plus 1 at 2 and minus 1 at 0. And then because it's a vertical dilation of 3, both of these points are going to be down 3. So it's at 2, 1, 0, negative 1. 1, 0, negative 1. Graph paper. I'd almost prefer to do these problems on graph paper. All right, last one. This is the test yourself problem. See how you can do with this one. Pause the video, try it out on your own. I'm going to kind of silently work my way through it, and then I'll talk about it in about 2 minutes when I'm done. Let's see. So x, y, it's 1 over x, so it's 1, 1, negative 1, negative 1. And what are we going to do to these coordinates? We're going to do a x-axis reflection. We're going to do a vertical dilation by a factor of 4. X plus 5. Oh wait, I like to do ups and downs first. Minus 3 is down 3, and then x plus 5 means left 5. What this means to the coordinates, if you're going to go left 5 on the x, it's going to be x minus 5. On the y coordinate, x-axis reflection, a vertical dilation of 4, so negative 4y, then down 3, minus 3. 1 minus 5 is negative 4. Negative 1 minus 5 is negative 6. Negative 4 times 1, negative 4 minus 3 is negative 7. Negative 1 times negative 4 is positive 4. Minus 3 is 1. So this graph is always going to pretty much look the same. But because of the negative 4, instead of going like this, it's going to be reflected over the x-axis. So instead the graph is going to look like that. My horizontal asymptote is at y equals negative 3. My vertical asymptote is at x equals negative 5. And then that means that these two key points are at negative 4, negative 7, and negative 6, positive 1. All right, if you're graph paper, think about it this way. You put in the vertical, you put in the horizontal asymptotes. Because of x plus 5, you know it's going left 5, so you put this in at x equals negative 5. Because of this minus 3, you know it's going down 3, so you put this at y equals negative 3. So then your key points, They're going to be 1 away from the vertical asymptote on both directions. So if this is at -5, this would be at -4, this one would be at -6. And then because it's 4, the vertical dilation is 4, it's 4 units away from -3. So if at -3, if you go up 4 units, you end up at +1. Or if you're at -3 and you go down 4 units, you end up at -7. Graph paper, gotta admit, it's the way to go on this one. But I still like doing problems this way. It's just habit. Don't forget, in terms of showing your work, you need to show this, or you need to show this. You could always be redundant and show them both. No worries. I forgot to do domain and range on number 4. I'm just going to do domain and range on number 5. The domain, it's all values except at -5. So -infinity to -5, softs, and -5 to infinity. The range, same thing except for -3. -infinity, -3, union, -3 to infinity. You know what? On second thought, I didn't do a range like, or domain and range like number 4 in the previous problem, so I need to go back and do that. Number 4, this one is the 1 over x squared, so the domain and range looks a little bit different. The domain still goes -infinity to +1, and then union 1 to infinity. The range on these ones, these are a little bit different. It goes to -infinity up to 0, and then that's it. So -infinity to 0, no union, just that. All right, part 2. It's backwards problems, where you're given a graph and you need to write an equation. And on a quiz or a test, I'm going to ask you to list the transformations on these. And I'm going to kind of cop out. For the first one, I'm basically going to look at the graph that I just made, and I'm going to kind of reverse the role and make an equation for it. So if I got this graph, how would I figure out that it's this equation? Let's see, how am I going to do this? There we go. Okay, paper to work on, graph to look at. So this graph here, because the horizontal asymptote's at y equals 2, you know it's gone up 2. Because this horizontal or the vertical asymptote's at 1, +1, you know this graph has gone right 1. Then use your look to figure out what that look, whether there's a reflection. We're used to a 1 over x squared going up, but this one's going down. That means there's an x-axis reflection. And then last but not least, the distance from the asymptote gives you the vertical dilation. Where this is at 2, but this y coordinate's at -1. That is a distance of 3. That means it's a vertical dilation by a factor of 3, which means our equation, and it's the 1 over x squared variety, so it's y equals, because of the right 1, it's x, let's see, right 1x means x minus 1, quantity squared, vertical dilation by a factor of 3 with an x-axis reflection, so -3, and then up 2, so +2. So I've listed the transformations, which will be 1 point, and I've written out the equation, which would be a 2nd point. Okay, I'm going to do the same thing with number 5 from part 1 now, but I'm going to give you a process to use, just a little bit of a list. So when you're doing these problems, here's the graph. First, yeah, I like to look for translations first, and translations come from the asymptotes. So in this problem, I have x equals -5, so it's left 5, and I have y equals -3, so down 3. Next, I use I look for reflections and I just look for the look of the graph. I'm used to a 1 over x doing what 1 over x does, this and that, but this is doing the opposite. It's been reflected over the x-axis. Then the third thing I look for is the dilation, the vertical dilation. And for that, you look for the distance from the asymptote. And in this particular case, it's at the asymptote's at -3, but this y-coordinate in both of these directions is a distance of 4. 4 down for this one, 4 up for that one. So it's a vertical dilation by a factor of 4. And then you combine all these ideas and you put it into an equation. It's the 1 over x variety, so on the denominator I don't need to really put parentheses like I did on this last one. I just need to write, it was going left 5, so x plus 5. It was x-axis reflection with a vertical dilation of 4, so -4, oops, not -4x, just -4, and then down 3, so -3. Okay, everybody. Whew! I think that was the longest lesson of the semester. My apologies. Look at the bright side. You got to meet Kyla on whatever thingamapop I was using. Have a good day. I'll talk to you soon. Bye-bye.